So, in gas laws, there are 3 states of matter: gases, liquids, and solids. There are also 4 main physical properties of gases: volume, pressure, temperature, and amount.
We solve for these 4 properties using these formulas.
Oh, dude, if you could get under it right there.
The first of these formulas is PV equals nRT. Here's what all these variables mean.
This is how you find the partial pressure, where you have the total pressure of a system and the number of moles for the gas.
You can see, you can probably see it that way, but like not at all.
Alright, to find the total pressure, you gotta get each individual pressure, add all together.
So this is the formula for finding Kelvin. K stands for Kelvin and the C is Celsius. That's fun.
Here's the formula for finding density.
This is how you find the molarity or the concentration of a solution.
We got the flashlight on, so everything's clean. You can't even make it past 1. Keep it up, Josh.
Alright, this equation is a mixture of these 2 equations and are used to find either pressure, volume, or temperature after one of these factors are increased or decreased.
No, I don't want to throw off my weight. Throw off the weight.
These are the 5 main postulates of the kinetic molecular theory.
Yeah, mine was actually really good. How long?
This is a mercury barometer. It measures atmospheric pressure. The atmospheric pressure pushes down here and causes this blue stuff, which is mercury, to come up here. And it measures the pressure in millimeters mercury.
An ideal gas is a gas that follows the 5 main postulates of the kinetic molecular theory. A nonpolar gas at low pressure and high temperature behaves most like an ideal gas. Hey, Rich.
STP stands for standard temperature and pressure. When STP is a problem, it means that the pressure is at 1 atm and the temperature is at 273 degrees Kelvin. At STP, 1 mole of gas is equal to 22.4 liters in volume.
For this example, we will use PV equals nRT, where P equals the pressures in atmosphere, which is 1 because it's at STP. V is the volume in liters, which is 43.9. And the number of moles, which we don't know. R, which is the gas constant, 0.0821. And T, the temperature in Kelvin, 273.
For this equation, we use STP. So that means 1 atm for the pressure, 273 degrees Kelvin for the temperature, and the gas constant, 0.0821. We also use the 43.9 liters that we are given in the equation. That leaves the moles as our unknown variable. Once we multiply these 2 signs out, we get 43.9 equals 22.4 N. This reduces down to 1.96 for N. That's 1.96 moles of aluminum. And so we multiply that by the molar mass of 26.98, and that equals 52.9 grams of aluminum.
The purpose of this lab is to find the number of moles of carbon dioxide produced when you mix HCl and laundry.
Step 1. Be wise. Protect your eyes.
These are all the materials you will need in this lab. Pipettes, a rubber tube, a large and small graduated cylinder, something to hold the detergent in, a large beaker, and a small beaker with a silent arm. In addition, you need to have the detergent, the hydrochloric acid, and an electric scale. Step 1. We have to measure out 5 grams of the detergent. First, you want to make sure that you zero in the weight of the bowl in order to easily find 5 grams. Next, we will put the detergent in the bowl. That is a little bit too much, so we will take some out.
Wow, nice tea.
And that is close enough to 5 grams. You want to make sure that you write this down in your lab notebook so you know the exact amount of detergent that you used.
Next, you will need to measure out 20 milliliters of hydrochloric acid. We're almost there, boys. That's 1 milliliter too much, but you get the idea. That's 20 milliliters of hydrochloric acid.
Now, we'll set up the experiment. We'll start by filling this big beaker with water. Next, we'll fill the graduated cylinder with water. Make sure it's as full as you can get it. Now there are a few air bubbles up here, so that's a error. Now, thread the tube into the graduated cylinder. And put the other one on the arm of the sidearm flask.
Now we pour the HCl that we measured out previously into this flask. Be careful not to spill any.
Next, you pour the detergent into the siren flask to start the reaction.
And seal it as quickly as possible so no gas escapes.
And make sure that you hold the graduated cylinder so it does not fall over.
Wow.
I'm just begging for attention.
Science rules. This doesn't make up for all the packets that we got in this class.
Where'd you find that huge beaker? In there?
Yeah.
Oh.
No, we brought it
You
ourselves.
could use this thing. You brought it yourself.
It makes it easier to
You
see.
go to the supply room.
We actually didn't though.
Next, we measured out the amount of gas that was collected in the graduated cylinder. Looks like about 213 milliliters.
Now dump the water out and dispose of the HCl detergent down the sink with excess water. Oh, look at that, it's cool.
Here's the equation you'll use for these experiments. And here's also the data table that we set up that has the grams of Na2CO3, it has the milliliters of 1.0 molar HCl, and the amount in milliliters of CO2 that we produce. We also measure the outside pressure and the water temperature. We just look this up on the phone, and then we use a thermometer to calculate this.
Before we can calculate the moles of CO2, we need to calculate the outside pressure. When we looked it up, we got 30 inches of mercury, which we have to convert to ATMs. So we do that by converting it to millimeters mercury and then ATMs. And we got this. But of course, there are only 3 sig figs, so we got 1.00 atmospheres.
So we looked up the water pressure on Google, and that's what we got. This is the work to convert it into atmospheres. We brought it down to 3 sig figs to get this many atmospheres. And to find the pressure of carbon dioxide, subtract the outside pressure from the water vapor pressure to get 0.98 atmospheres. That's the pressure of the carbon dioxide.
Now that we have all of our data, we can use PV equals nRT, our work is shown here, to find the exact number of moles of CO2 produced, which we ended with 0.01.
Here is the equation for molar mass. And here's the problem. An ideal gas sample weighs 2.39 grams at 238 degrees Celsius and 2.11 ATM, and has a volume of 1.361 liters. We need to determine the molar mass using only these values. First, we have to find density. So we take the grams divided by the liters to find the density, which is 1.76 grams per liter. And then we plug that into the equation with the rest of the values to find the final answer of 34.99 grams per mole.
Find the total pressure of a container that has 21 atmospheres of oxygen, 10 atmospheres of carbon dioxide, and 9 atmospheres of nitrogen. This is an easy problem. All you have to do is add all the pressures of the container, because they're the partial pressures. According to this equation, all I have to do is add them up to the total pressure. That is 40 atmospheres total.
These 3 graphs all involve the PV equals nRT equation. This graph involves pressure and volume as you keep the moles and the temperature constant. As you increase the volume, the pressure will decrease. This graph involves pressure and temperature. It has moles and volume constant. And as you increase the pressure, the temperature will increase at the same rate. This graph involves volume and temperature and has moles and pressure as a constant. And as you increase the temperature, the volume will increase at the same rate.
This is a balloon at room temperature. If we increase the temperature, the particles get farther away from each other and the volume increases. When we decrease the temperature, the particles get denser and closer together and the volume decreases.
I stopped it.
That means
Hey, don't forget there's a class right here. So, what class is that?
This is a mercury barometer. You use it to measure the atmospheric pressure. The blue stuff in here is mercury, and the air pressure in the
Gas that follows the 5-way process. A non-polar gas that an ideal gas is a gas that follows the 5 main postulates of kinetic and molecular theory. Non-polar gas is low pressure, temperature.
STP stands for standard temperature and pressure. When STP is in a problem, is standard pressure is at 1 atm, the temperature is at 273 degrees Celsius. STP stands for standard temperature and pressure. When STP is in a problem, it means that the pressure is at 1 atm, the temperature is at 273 degrees. STP stands for standard temperature and pressure. When STP is in a problem, it means that the pressure is at 1 atm, the temperature is at 273 degrees Kelvin.
Here's an example problem. In this problem, we will use PV equals nRT, where P is the pressure in atmospheres. Step 1.
Measure out 5 grams of detergent. Make sure you zero. Make sure you zero the bowl thing out.
Okay, this isn't
actually the question.
not
I know, okay.
Measure out 5 grams of detergent. You first want to make sure to zero the bowl so that you can easily find 5 grams. Next, we're going to use a scoop in order to measure out the detergent. So we got a little bit of so I'm going to take a little bit of it out.
I'm at South. No, you have some over here.
That's fine. We'll clean that up because we are very professional.
Alright, now we have to add a little bit more. So we're going to take this because we don't waste.
No.
Here's the equation you will use for your experiment. And make sure that you...
On the news today when they wore mustaches, and it was funny.
Oh, wait. I mean, I get there like 5 minutes.
Yes, sir.
don't start a riot.
Here are 3 graphs that all involve the PV equals nRT equation. For example, as this.
We can go whenever.
Everyone, we need to stand on one side.
That's what I was like.
We gotta go at the same time.
Richard's getting a little cold.
Watch his hair blow.
Hey, that's that.
I have so many questions.
Me and straight.